But where does it come from, right? So right now it comes from underground, which is fine. It's served humanity very, very well. We've propelled ourselves to the civilization that we are today, essentially through drilling oil and burning it, and that's awesome. But I think we can do even better. The way that we do even better is that we are eventually going to get hydrocarbons from the air. What do I mean by that? Well, the air already has all of the ingredients for a hydrocarbon. It has carbon and hydrogen, right? So the carbon is in CO2, which is everywhere in the atmosphere. The hydrogen is from water, which is also everywhere in the atmosphere. And all you need to do is energize CO2 and water. So it's sort of, think about this like reversing combustion, right? So when you have combustion, you start with a hydrocarbon and you mix it with oxygen and you get energy out of that and you get CO2 and water, right? So that's combustion in a normal engine. We kind of do the opposite. We start with those combustion ingredients, the CO2 and the water. We put energy back into them and we get a hydrocarbon. So I believe that that process will be driven by nuclear. And what that means is we're essentially using hydrocarbons as a distribution mechanism for very cheap nuclear power. So if you have a bunch of nuclear reactors all on a campus, again, we call this a gigasite, you're producing huge amounts of power, and we can certainly push electrons in a wire and produce electricity, but we can distribute all of that valuable energy in another way, which is to build hydrocarbons and then ship the hydrocarbon, right? So this is like us producing energy, forming it into a hydrocarbon, and then shipping that energy in the form of a hydrocarbon. And I do believe that as nuclear becomes cheaper and cheaper, that the price of that hydrocarbon is going to become significantly cheaper than oil. It'll become cheaper than drilling oil and refining it and distributing it.
Interesting.